Hello, welcome to another video. As promised, I'm going to be explaining some basic concepts as an introduction to matrices. Now I know that matrices could get very complex, but I want you to know that I'm starting from the basic beginning. So if you already understand all of the things I'm going to say at the beginning, just do me a favor, like the video and get away. But if you still want to watch my video just because you think it's fun, or you might learn something, you can join me, okay? But I'm starting from the very basic concepts that involve matrices. So let's get into the video. So the very first thing I'm going to talk about is the definition of a matrix. As you can see, it's basically a rectangular array of entries. Now those entries are sometimes called elements, sometimes we just straight up call them numbers, and sometimes we just leave the name as entries. Now, for the sake of the basic explanation, let's take them as numbers, okay? Sometimes they are letters, like you see in this example here. Sometimes they are functions. Sometimes they're just names. It doesn't matter what it is, as long as you arrange them in a rectangular array, those entries they form a matrix. Okay, so that's out of the way. The next thing we want to talk about is how you write a matrix. These are 3 examples of how you write a matrix, but one of them is incorrect. Remember, we said it must be a rectangle. And the way you're looking at it, it looks like this is a rectangle, this is a rectangle, but this is not a rectangle. But that's not what you call a rectangle. It is the arrangement that has to be in a rectangular form, but the notation and the bars that are required for it to be a matrix must be like this, with this top and bottom curls inside or curves inside, or it just has to be like a giant parenthesis, but it cannot be straight bars this way. This is not a matrix. It is a representation of the determinant of a matrix. So do not write your matrix with straight lines. You have to put the curl on top and on the bottom, or just make curves. So these 2 are correct. This is incorrect. This is the determinant of a matrix. This is a matrix, and this is a matrix. This is not a matrix. Okay, those are the 2 ways you can write it. And I have a problem with the curls, although that's what I find myself trying to do all the time. But I think if I do the curls like this one, it just saves me time and it looks more like a rectangle than if I do this, because I catch myself bending the curves. So now you know how to write a matrix, these 2 ways. We're going to come back to this in the future when we talk about determinants. But for now, shelve this, do not use it. We're using this and using this as representations of matrices. Now let's move on to the next thing we need to talk about. How do you name the things that are inside? If I want to tell you that what is 2 in this matrix, what would be the name? Let's see an example. Now we want to learn how to name the elements in a matrix, okay? So I have a matrix here that has the elements 2, 1, 0, 2, -1, and 3. Let's say I want to identify the first 2, because you see there are 2 2s here. I can say, okay, so what's going on with this 2? I can name it in such a way as describing this matrix as this. Because I use capital letters, so generally, let me say this, we usually would name the entire matrix in capital letters and name the entries or the elements, or what you call the numbers inside the matrix, with the small letter corresponding to this. So I'm going to name this as A, and I'm going to name this also as A, as A, as A, as A. But how do we differentiate them? All we have to know is what position they are occupying. And in order to know the position, you must know how to name these horizontal lines that run through them and the vertical lines that run through them. So, and that brings us to the concept of the dimension of a matrix. Now, if I have to run a strike through with my fingers horizontally from right to left, so look at this. If I have to strike through, I will need 3 fingers to strike through these numbers. So I'll have to draw 3 horizontal lines, and those horizontal lines are what we call rows. Rows are horizontal. And if you have to strike them vertically, you call them columns. Columns are vertical. So as you can see, A has 3 rows and 2 columns. Do not switch that. You can't say, oh, I want to first name it as 2 columns and 2 rows. No, you always say rows before columns. It is the most important thing about how to name a matrix or how to perform many of these operations we'll be talking about. You name the size or the dimension or the entries of a matrix depending on their positions in the rows and the columns. So you must know the row, you must know the column. So this is a matrix that has 3 rows and 2 columns, so that this first number here is the first entry occupying the first row and the first column. 1, 1. So we name this as A sub 1, 1. When you move on to this one, you're going to name it as, this one here is occupying the first row but the second column. You name it as A, 1, 2. This is occupying the second row but the first column, so you name it A, 2, 1. This is occupying the second row, the second column, you name it A, 2, 2. Third row, first column, A, 3, 1. Row before column. It is important that you remember R before C, RC circuits, especially for those who are going to be doing any kind of engineering, mathematics, or if you're doing in any STEM field, you'll have to deal with matrices as you keep going. Okay, and finally, this one is going to be A, occupying the third row, the second column, A3, 2. So instead of me saying the 2 that is in the second row, all I have to say is A2, 2. That's all. I know which of these elements I'm referring to. It is essential that you can name the entries of a matrix. And you can also name the size of the matrix. So, let's talk about the dimensions of matrices. I don't want to erase this. I'm going to use these examples and we're just going to write out all the dimensions of all the matrices I have on the left. Okay, so let's do that. The dimension of a matrix is simply a statement of the number of rows and the number of columns that it has. Do not mix it, do not flip it. The dimensions is row times column, RC, R by C. Okay, so let's go here. This is a matrix. It has 2 rows and it has 2 columns. So we say this is a 2 by 2 matrix. This also is a 2 by 2 matrix. Now tell me, what is the dimension of this matrix? It has how many rows? It has 2 horizontal strike-throughs and 3 vertical strike-throughs, so it is 2 by 3. What is the dimension of this? The same thing, 2 by 3. Is this a matrix? Yes, I know. Because you're dealing with matrices, this is a matrix. What is the dimension of this matrix? How many strike-throughs do you need for this matrix? This is going to be 1 strike-through, 2 vertical columns. This is a 1 by 2 matrix. Let's go here. This is a 3 by 2 matrix. This is a 3 by 2 matrix. This is not 3 times 2, so don't write 6. Okay, we're just showing the dimension. Here, this is a 2 by 2 matrix, and this is a 2 by 1 matrix. this is a 1 by 3 matrix. Those are all the matrices that we have here. So in your head, just imagine a 5 by 7 matrix and just fill it with numbers. It doesn't matter, okay? Number 2, please, there are no fractions in the dimension of a matrix. There is no 1.5 by 4 matrix. No. Okay, so, and this is basically what you have here. It's just an introduction. Now you know what a matrix is. Now, why do I need to know matrices? The point is, instead of you making tables, school A, male teachers, female teachers, number of those teachers that are married and those who are not married, and then you put those numbers there, and then you go to school B, you do the same thing, but now you want to add all the schools in the entire state together. A matrix could just do that for you. Instead of you punching calculators, you already have the matrix, okay? Or maybe you want to increase the grades of all your students in the class in different tests. You already set it up as a matrix. There's some things you can do that just do everything for you together at once, okay? All the animations you see today and all those things you see in programming, matrices, okay, matrices. So just understand that this is what we have, and then we can perform these tiny operations. So now I want to tell you what you can do with a matrix and what you cannot do in terms of basic arithmetic operations. Number 1, you can multiply a matrix by a scalar, as in this case. And I'm just going to do it now. If you have a matrix and you have a scalar is any number that is not a variable and is not a matrix. So remember, we're not doing x, we're not doing y. What we're doing is we're multiplying by a scalar, okay? You can multiply a matrix by a scalar, not a matrix by another matrix. We're just saying, first things, and if you multiply, it's just the basic multiplication. 1/2 times 1, 1/2 times 10. So the new matrix, the result of this is going to be 1/2. And the second entry on the second column will be 5. This is the answer to this multiplication. You don't need to put commas, just put sufficient space between the entries. Okay, no commas, because if you put a comma here, then it becomes a coordinate of a point and we're no longer doing linear algebra. Okay, you leave that. So you can multiply a matrix by a scalar, you just do the multiplication. It's basically the multiplication of the individual entries. Let's go to this, let's do this. If we multiply this by 2, our answer is going to be 2 times 1 is 2, then we have 4, then we have 2. This is just a number. You cannot add a number to a matrix. You cannot subtract a number from a matrix. You cannot subtract a matrix from a number. You cannot perform this operation. If it is a matrix, you can subtract another matrix from it if both of them look alike, but that's all you can do. You cannot add a number. You cannot say, oh, I want to add 3 to all of these. What can I do if I want to add 3 to all of these? Well, you'll have to go find a matrix that has all 3s. So if you want to add 3 to all of the entries here, you will have to create another matrix that looks like this. And then you add it to this so that the corresponding entries will just take up new 3s. But you cannot just say 3 and then add it. Okay? Now, as we go on, you can figure it out that you'll be able to do some other things later, but I don't want to make it complicated. So you can add a scalar to a matrix. You cannot. Remember that. Now let's go to, so we've answered this question. We've answered this question. And this is all you can get. You cannot go beyond this point. So you cannot add a matrix to a scalar. Let's go on to another operation. Can you add, oh, what about this? So if I tell you that this matrix is equal to this matrix, what am I saying? All I'm saying is A is exactly 1, and B is 2, C is -3, and D is 2. You cannot change it. Okay? It's not like you go start solving an equation. You don't need to solve an equation in this case because what is here must be what is here. What is here must be what is here. So two matrices are only equal if they have the same dimensions and their corresponding entries are exactly the same. Okay, I don't need to emphasize that. Okay, so this simply implies that A is equal to 1 and B is equal to 2 and C equals -3 and D is equal to 2. That's it. Okay, let's go to something else. What about this? Can I add a matrix to another matrix? Before you can add any two matrices, the dimensions must be exactly the same. Then you can add. And you can also subtract. So, if I want to get an answer to this, well, I have to put my answer somewhere here and say that the answer to this will be 2 plus 1 is 3. 1 plus 0 is 1, and 0 plus 1 is 1. 1 plus 0 is 1, 3 plus 1 is 4, and 2 plus 1 is 3. This is the sum of these matrices. So addition or subtraction is just dealing with the corresponding elements or entries, and you don't have to do any complex calculations. Okay, let's go to the next one. This multiplication. Okay, can I multiply two matrices? The answer is yes, under one condition. Now that condition I'm going to explore in the next video, and that will be the focus of the next video, the multiplication of matrices, or just perform basic operations generally. But let's see, can I multiply this matrix by this matrix? Before I explain the concept behind it, I'm just going to say yes or no. Well, looking at this, you see the inner dimensions. This is 2 and this is 3. You see how I have this here? You cannot multiply unless the inner dimensions are exactly the same. So because this is a 3 by 2 matrix and this is a 3 by 2 matrix, the inner dimensions must be the same. If this was a 2 by 3, then you can multiply. Or if this was a 2 by 3, then you can multiply. But you can multiply this too, so this answer is not possible, does not exist, or cannot be done. Cannot be done. So you cannot multiply two matrices unless the inner dimensions are the same. The next video will be focused on matrix multiplication. So I'm not going to dwell on explaining this, but you can't do it because this number 2 is not equal to 3. Let's go to another multiplication. Let's go to this one. You can see my question is answered, or your question is answered, because 2 and 2 are the same. The inner dimensions. And look at the secret. If these two are the same, then the matrix you're going to get at the end will be a 2 by 1 matrix. That is, it will have 2 rows and 1 column. What do you think that's going to look like? So even before you do the multiplication, you already know what your answer is going to be. Your answer is going to be like, where is the matrix? It's going to be like this matrix. Okay? Because it's going to have 2 rows and 1 column. It's going to take up the characteristics of the outer dimensions. You need the inner dimensions to be the same, dimensions if you like dimensions, and the outer dimensions will be the result of the multiplication. So here, we're going to have an answer that looks like this. So let's see what we get. Okay. I don't want to do a lot of matrix multiplication because the next video will focus, but say I want to do this so you can know what the answer is like. I'm going to take the first 2 entries, I take this and place them like this. So look at this, you flip, you take the first row and you use it to multiply the first column. So this, but there's only 1 column, so 1 times this. So it's going to be 1 times 2 plus 3 times 4. 12. I will explain why we do that in the next video. And then you do the same thing. It's going to be this times this. So it's going to be 2 times 2 plus 4 times 4, 16. So that the resulting matrix from this, You see why I don't like using these brackets? It keeps tilting. It's going to be 14, 20. So the product of these two matrices gives you a column. So this is called a column matrix, and because it's just one column in it, and then you get 14 over 20. This is called a row matrix because there's only one row. Okay? If there's only one row, it's a row matrix. There's only one column, it's called a column matrix. No matter how many rows it has, no matter how many columns this has. In the next video, we talk about matrix multiplication, and maybe in another video, all the special types of matrices. See you in the next video. Never stop learning. Those who stop learning have stopped living. Bye-bye.